So our first example is going to be that I'm spinning the following spinner, and I'm going to find the probabilities for each of the different scenarios. So the spinner is going to be this one on the screen, and then all of these questions are going to relate back to this spinner. So the first one, event A, says the number is a factor of 35. So 35 would be, what are the numbers that evenly divide 35? And so my factors of 35 are going to be 35, 5, and 7, because all of those would multiply evenly to 35. So those are the numbers that are factors of 35. Now I am looking for which of those are on my spinner. And so on my spinner I've got a 1 and then a 5. And so there are 2 possible events out of the total of 6. Make sure you always reduce these down. And so I'm going to get a total probability of 1/3. Unless it specifies otherwise, just chances are leave these as fractions. Event B is going to be the number is even. So my even numbers on my spinner would be 2, 4, and 6. So there's going to be 3 out of a total of 6, and reduce that down to 1/2. The next one, the number is a factor of 12. So my factors of 12 are going to be 1, 2, 3, 4, 6, and 12. And so I'm looking for, well, what numbers listed of my factors of 12 are the ones on my spinner. So I've got 1, 2, 3, 4, and 6. And so that's going to be 5 out of 6, doesn't reduce. And so that will be my final answer for that one. Letter D, the number is a 3 or a 5. And so we've just got 2 of those out of a total of 6. And so I'm going to reduce it down to 1/3. And then event E is going to be that the number is 15. Well, there's no way on my spinner that I could spin a 15, and so that's going to be 0 out of 6 or 0. Make sure you do reduce that down. 0 out of 6 is an unsimplified fraction. Make sure you reduce that to 0. And then event F, the number is composite. Composite meaning it's not prime, that it can be broken down. 1, 2, 3 are prime, 4 is composite, 5 is prime, 6 is composite. And so I've got 2 out of a total of 6, or 1/3 again. And so here we've got another theorem. Theorem says the probability of an event is equal to the sum of the probabilities of disjointed events whose union is the event. All that means is if you see an or statement that you are going to want to add up those events. You're going to sum them. That's what disjointed events mean. So let's look back at event D. The number is 3 or 5. Well, what's the probability of spinning a 3 on my spinner? So the probability of spinning a 3 would be 1 out of the 6. The probability of spinning a 5, or my spinner landing on a 5, would be 1 out of 6. And so what that theorem says is the probability of spinning a 3 or a 5 is going to be the probability of spinning a 3 plus the probability of spinning a 5, which we've kind of did intuitively. And so I'm going to have 1 out of 6 plus 1 out of 6. Which is going to give me 1 out of 6 plus 1 out of 6 is 2 out of 6. And then still that was going to reduce down to 1/3. Same answer we got before, but there's just an official theorem that's going to help us later on, especially as we look through some more complex examples, even moving forward into the rest of chapter 9. So example 2 says, let S be the numbers 1 to 15. If a number is chosen at random with the same chance of being drawn of all the other numbers, so it's fair, calculate the following probabilities. The first one says, what is the probability of drawing an even number? Well, my even numbers, I'm going to just list off the event. So what could be even of mine would be 2, 4, 6, 8, 10, 12, and 14. Those are all the even numbers in my specific sample 1 to 15. And so the number of even numbers I have there is 7 out of a total of 15 numbers. And so that would be my probability. Event B says the number is less than 5 or more than 11. Well, we just learned the theorem up here that says I can add each of those parts. So what I can do is add the probability of less than 5 plus the probability of more than 11. Well, the numbers less than 5 are going to be 1, 2, 3, and 4. Can't include 5 because it has to be less than. And so those are going to be 4 out of 15. And then the probability of being more than 11 is going to be 12, 13, 14, and 15. So also 4 out of 15. And then I can add those together. And so because they already have a common denominator, I'm going to add the numerators and get 8 out of 15 as my probability. And then the last one with this example, probability is less than 5 and more than 11. So this one's different. That one said or. So we're going to go back now and highlight that. This says the probability of one or the other happening. And they both have to be true. And so with the probability of less than 5 and more than 11, there has to be a number that satisfies both conditions. So I have my same scenario in terms of the same numbers. However, there is not a number that is both less than 5 and it's also true that it's more than 11. And so my probability for that one is going to be 0 out of 15 or 0.